Okay, I am once again back in an empty room, trying to fill in some gaps and things that haven't been covered yet. So this is part 3 of Algebra 3, 1 through 20 review. Happens to be our quarterfinal. 2 other videos are going to cover the other questions, and so I'm just going to cover what's not covered in those 2 videos. All right, so we're going to start off with question number 6. Okay, hopefully I've got everything rolling here. I'll double check on it. Yep, all looks good. All right, question number 6 says factor 64y to the 12th minus 8 x to the 9th z cubed. Okay, let's see. This to me looks like a difference of 2 cubes. So I would want to start by cube rooting each of the different elements. Okay, so we'd want to find the cube root of 64. Okay, which I believe is 4. Let me check here real quick. Oh, let's see. Math 4 64. Yep, 4. Okay, we're going to get 12 divided by 4 is 3. Cube root of 8 is 2. Cube root of x to the 9th is x to the 3rd. And the cube root of z to the 3rd is z. Okay? So let's see. Let's actually look at what our formula should be. It should be f minus s times f squared plus fs plus s squared. Okay? All of that has to be those operations. Okay? So our f is 4y cubed. Our s is 2x cubed z. So then we just follow the formula. So we want f squared. So we want 4 squared, which is 16. We want y cubed squared. So we actually multiply the 3 times the 2 to get y to the 6th, plus, just like our formula shows, f times s. So 4 times 2, not 4 times negative 2, but 4 times 2 is 8. They don't share any common variables, so we just bring them all across. We can do x, y, z, x cubed, y cubed, z, plus s squared, which is 2. 2 squared is 4. X to the 3rd squared, so that's 3 times 2 is 6. And then finally z squared. Okay, I'll double check that against our answer key just to make sure I haven't said anything that's wrong. This is question number 6. Okay, so they actually do something a little bit different here, and we could have done this and probably should do it. So this is a good example of, not slowing down to take a look. If you look in here, we can factor something out of both of those, and we can actually factor out, I'm trying to look at what they're doing here. So right off the bat, they do something rather interesting, and so we want to pay attention to this. Okay, coming all the way back up here, so I apologize. They actually factor out an 8. Okay, so they take 64, divide it by 8 to get 8. Okay, so they pull out an 8 here, and that leaves them with, let's see, 64 divided by 8 should be 8. 8. Let's see. Actually, this almost looks like a totally different question, but it's 5b. Okay, let's take a look. 64y to the 12th minus 8, 9. 8 to the 9 is x to the 9th z to the 3rd equals 8. Okay. All right. So that leaves me with 8y to the 12th minus 1 x to the 9th z cubed. Okay, so we get something like that. Now, we're going to leave this 8 on the outside, and we're going to cube root these things here. Okay, so the cube root of 8 is 2, and then we kind of get back to, sorry, what we had before. 2y to the, we've got 12 divided by 3 is 4. Okay, 2y to the 4th minus, and the cube root of 1 is still 1. Okay, so you could look at it like that, x to the 3rd z. Okay, and then we go back to our original formula over here and do what we should do. So 2 squared is 4, y to the 4th squared is 8. Okay, make sure that nothing I'm doing is wrong. Plus, okay, let's see, this is a little different. Okay, so 2 times 1 is 2, and we can do our x, y, z, x cubed, y cubed, z, x cubed, y to the 4th, all right, 4th. I must have made a mistake the first time around. You guys are going to be really frustrated with me by the end of this. Okay, it's been a long day. 2x cubed, y to the 4th, z, plus 1 times 1 is still 1, so you could put a 1 there. That's going to be z, oh gosh, I'm going to be able to think. X to the, should be the 6th, z squared. All right, so finally, we get the actual answer, which is this right here. So you saw a really good example of how to do it wrong the first time through. So look through here and see if you can factor anything out at the very beginning. Okay. All right. Up next will be question number 7. Question number 7. All right, gives you 3x to the 8n plus 2 minus 9x to the 5n plus 3. Okay, and I know that this was marked off originally, but I'm going to let you do it. But what we need to do first is we need to break everything down into its prime numbers. Okay, so 3 is really just 3. It's a prime number already. But x to the 8n is x to the n 8 times. 3, 4, 5, 6, 7, 8. And then this 2 here is x times x, okay, or 1 and 1. So all of this that you see here is 3x to the 8n plus 2 drawn out into its most basic parts. Okay? Now, for the negative 9, okay, negative 9 would be negative 3 times 3 times x to the n 5 times. 3, 4, 5 times x times x times x to get your x cubed. Now, to factor out, we have to look at what we can take out of both parts. So we can take out 1 3 here and a 3 here. So that 3 is going to sit there. We can take out 5x to the n's. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. So we've got x to the 5n. Okay, we can take out 2 x to the first. So that would be plus 2. And that's all they share in common. So what we put inside then is whatever's left. So we have, looks like x to the 3n. Okay, doesn't look like there's anything else there. Okay, minus 3. And looks like x. Okay, let's check that against the answer key. 3x to the 5n plus 2 times x to the 3n minus 3x. So this right here is our answer. All right, after 7 is 16. 16, which is a proof. Okay, so we got our statement, we got our reason, okay, and they give me something that looks a bit like this. Okay, we've got Q, T, V, U, and R. Okay, let's go through our givens. They say that QR is congruent to UV. All right, so with that, we can go ahead and put that in. QR, so that's this length right here, is congruent to UV. Now notice that it said QR to UV. So Q is to U as R is to V. Okay? That's going to be important when you start looking at different angles. All right, QR is parallel to UV. Okay, so this is running parallel to this. All right, these are both given. And what is it that we want to prove? We want to prove that the two triangles are congruent. All right, so what we should see is that if I have two parallel lines, then anything that crosses those two parallel lines is a transversal. Okay, so that means that this angle, okay, is congruent to that angle, because angle, let's see, that would be QRT, is going to be congruent to angle, let's see, we said QRT, so we're going to say UVT. And these are alternate interior angles postulate. And the alternate interior angles postulate essentially says that if I have two parallel lines cut by a transversal, then the alternate interior angles are congruent. And that's kind of the full thing. All right. Let's see. There's different ways to do this. We could also, by the same standard, show that this angle is congruent to this angle by the exact same rule. So that would be angle RQT congruent to angle VUT. Those are also alternate interior angles. Okay, but they run off of a different transversal. Okay. Now, we could also say, we don't need to say this, we have two angles, but just so that we see it, we could also say that angle QTR is congruent to angle, let's see, UTV. Okay, UTV. So what we're saying is this angle is congruent to this angle because vertical angles are congruent. Okay. Now, they've already told me that I've got a side congruent. So there's actually a couple different ways that we can prove that these two triangles are congruent. Okay, we got triangle QRT congruent to triangle UVT. One thing I could use is I could say angle side angle. Okay, you can see angle side angle being done here. Angle side angle congruency postulate. Okay. We could also say angle, 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 side congruency postulate. Okay, either one of those two would work. You don't have to use both of them. I just wanted to show you as much information as we can here on this. Okay, so there's 16. We also need to look at 17. Okay, 17, simplify by factoring the numerator. Okay, well, we got x to the 4m minus y to the 4n. And before I get very far, I do want to take a look at 16's answer key and make sure I didn't mess that up. Let's see, if two parallel lines are combined transversely, each pair of alternate interior angles are congruent, vertical angles are congruent, given. All right, angle, 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 side congruency, posture. Yeah, so they use all the same things. Okay, let's get back to number 17. Okay, x to the 2m. This is another one that was originally marked off. Y to the 2n. All right, give me a second here. And what says simplify by factoring the numerator. Okay, give me a second to pause. All right, I'm going to have you do this differently. We'll see if I get the right answer out of this. But what I would do with this is I would split the fraction. So x to the 4m over x to the 2m, okay, plus y to the 2n. We'll see if we can do this. We may not be able to. Let's see. Okay. What I would do here, again, I might really be messing this up, and okay, but I would move that x to the 2m up. All right, so I'd get x to the 4m. Ooh, and we can't do that because we have plus down here, so I can't just move those things around. So let's go back to what they're actually suggesting, and I'm just going to show you what the book shows, and if it makes sense, it makes sense. If it doesn't, again, there's probably a good reason why originally I said don't do this question. Okay? All right. So what they show you is they have you kind of factor out the numerator. So what they mean by that is they take x to the 2m squared, and that's what would give you 4m, okay, minus, and they do the same thing with the y, so they do 2n squared up here like this. Now they leave the denominator alone so that you get x to the 2m plus y to the 2n. Okay, and there's your first step there. Okay. I got to catch on to what they're trying to do. Well, I'll show you. Okay, so in their numerator, they leave the denominator alone completely. So they have x to the 2m minus y to the 2n. They give x to the 2m plus y to the 2n, all over our common denominator, x to the 2m plus y to the 2n. Just reminding myself why I don't like this question. Okay. So what ends up happening here, if you come back to this, what you'll notice, okay, is that the x to the 2m plus the y to the 2n cancels out, and what you're left with is x to the 2m minus y to the 2n. And so they use that and they say, you know, hey, there's your answer. So anyway, not a great question, probably not one I would do. Okay, let's look at 18. Hopefully this will go a little bit smoother. Find the equation line that passes through 2, -2, and is parallel, okay, parallel to x plus 3y equals 4. The first thing I would do is go ahead and take that equation here and turn it into slope-intercept form. So I've got 3y equals -x plus 4, divide by 3, y equals -1/3 x plus 4/3. We don't really need the 4/3 at all. We really just need this. We just need the slope because we're looking for an equation that's parallel. So we're going to use our y minus y1 equals m times x minus x1. Okay, we're going to use these coordinates for x and y, and then we're going to plug in our -1/3. So y minus -2 equals -1/3 times x minus 2. Okay, we can go ahead and consider that plus. We'll do y plus 2, distribute the -1/3. Okay, -1/3 times 2 would be the same as -1 times +2, which would be, or sorry, -1 times -2, which would be +2, which would be +2/3. Okay, and finally we want to add 2 over here. Okay, add 2, which is 2 over 1. Okay, so we got y equals -1/3 x, and we've got 2/3 plus 2. Let's go ahead and get a common denominator, multiply by 3 over 3, which is same as 6/3. 6/3. So 2/3 plus 6/3 is 8/3. So our final answer here is y equals -1/3 x plus 8/3. All right, so I did make a mistake in here, and I don't know how many of you would have caught it, but I didn't balance my equation correctly because I have to subtract 2, so I need to subtract 6/3 right here. So I should get y equals -1/3 x, but I'm going to get 2 minus 6, which is -4/3. -4/3. So this is what we want instead. So, all right, we need about 2 more questions. We need number 19. 19, it looks like this. We have 160 degrees here. We have x degrees here. We have 50 degrees right here. So our formula is major arc minus minor arc divided by 2. Okay, should equal our outside arc, outside angle. Okay, so here we just substitute what we have. Okay, in this case we know our major arc is 160 minus x divided by 2 is going to equal 50. Okay, multiply by 2. Okay, so we should get 160 minus x equals 100. Subtract 160 from both sides. Negative x equals -60. Divide by -1. X should equal 60 degrees. But I'm on a roll with not getting these right tonight, so let's double check. 19, 60 degrees. Very good. Last question, number 20. All right. We got 5 here, 6 here, 3 here, x here. These are fairly simple. Okay, so it's the product 3 times x is going to be equal to 5 times 6. Okay, so 3x equals 30. Divide by 3. X equals 10. And that's the same thing we get in our book. All right, that's it. Sorry for getting these out late. Hopefully that's a help and you guys do well on your quarterfinal. All right, good night.